depending on the location. Further south, we want a battery. Here you can see how it terrain follows. The tables are independent. It's that drive shaft that flexes over the ground. So it would eliminate any need for cut and fill, which isn't allowed on these brownfield sites. And we have the typical features of a tracker, you know, backtracking. And that's it there for that video. So here's an example of a large, quite large, probably, you know, some of the largest brownfield solar sites in North America. We did one in Alberta. It's 55 megawatt. It uses our core fixed tilt ground mount, 8,551 of the foundations. It was cast in place. Cast in place is good if you have undulating ground, because it allows adjustment within the racking prior to bringing in the cement and pouring. So we're able to adjust the racking to conform to the ground. And then we brought in trucks. It had good access. There wasn't weight restrictions. So we were able to bring the cement trucks directly in through the site into the rows and pour in place. So that was a big savings in having to have an additional step of, you know, transferring to a smaller skid steer. Again, kind of the sister site of this, a 39 megawatt. Also, it's in a sort of residential area within Calgary, old fertilizer landfill. Again, 39 megawatts. It used our dual post core fixed tilt racking. Again, undulating ground. It was good for pour in place, and great accessibility for the cement trucks to come in and out of the site. So there is less material handling of the cement product. Norway, Maine. It's approximately a megawatt site, 327 tubs, cast and plate. Again, due to site weight restrictions, we had to transfer. The cement truck couldn't come on the cap, so we had to transfer to skid steers with buckets and then pour in place at the tub. You can see the tubs there. They're quite easy to install. Sometimes you'll pack gravel to level the tub, but in general, you can see this is sped up, but it's about a minute to set up one of our tubs, and then you would assemble the rack and then pour the cement within the tub, and then the galvanized sheeting would remain on the block throughout the life of the project as well. Here's an example of our Gabion basket design. This site was good because there's readily available material. Some customers like it because it projects more of an environmental type site. It is under a megawatt core fixed tilt, 327 Gabion baskets. So it's a wire basket that you fill. Sometimes it'll be mining tailings or other readily available stone. Here's the sites are very clean looking when they're done. Here's a cast in place site where you can see they used the polar tub, and it's very clean looking. The site was built, you know, very little or no cut and fill, conformed to the terrain, so there's no water runoff or sediment or anything like that happens. So the big thing on a lot of these landfills is they don't want to disturb the vegetation to run into erosion issues. So basically, you know, the bringing in the tubs and the, you know, pour in place, cast in place, and having the terrain following allows for very little vegetation disturbances, which is key in a lot of these projects.
Thanks, Robert. So yeah, thanks for the insightful information, Robert, from site. You know, we kind of wanted to summarize some of the key takeaways here for this webinar, and basically, again, can't believe it. There's over than 500,000 brownfields and landfill sites in North America, which already around 200,000 of them identified in the U.S. already as potential solar bright fields. Ballasted foundations repurpose otherwise unusable land. I actually personally looked it up a few times and I couldn't find another way to repurpose unusable land except for building a solar farm on it. Another key takeaway from Robert's presentation is planning construction ahead of time. It will help define the ideal ballasted foundation for your site conditions. The Gabion ballasted are ideal for sites with readily available rocks. The precast for sites with challenging weather and site restriction, and the cast in place for sites with undulating terrain. One of the main takeaways here is the polar racking single axis tracker. It is available with ballasted foundation, and due to the few things that Robert mentioned, but again, we want to highlight it here, is designed to accommodate differential settlement without impacting the single axis performance, the single axis tracker performance. That's mainly due to the independent table design that allows the terrain following, since all of them are driven by a flexible drive shaft. Also, the capability of our tracker to stow at 0 degree position, it reduces and it minimizes the reaction loads, and thus it driving smaller ballasted designs, less concrete, less cost, less everything on site. Some of the other products and services that Polar offers, we offer our core product, which is the utility scale ground mount solution for large scale projects. We also offer the distributed ground mount core flex for any projects that are less than 1 megawatt. We have the single axis tracker, as you guys have seen in the video and throughout the presentation, and we have different carport designs for your project. So we've got the long span, the L shape, the Y shape, the pie shape, the different designs that could meet your project terrain and conditions while maximizing the energy yield. Polar Racking also offers the following services. We offer civil engineering designs, stamp packages, and construction installation on site throughout the US and Canada. A little bit more about Polar Racking. Polar Racking is a North American leader in the design, engineering, and manufacturing of PV mounting systems. We've been the leader in the industry for over 14 years now. We have over 3 gigawatts of experience, installing experience across the various products that we offer. We have staff that support our projects in New York, Ohio, Calgary, and in Toronto. We also support our North American clients from our manufacturing facilities in the US, that's in Michigan, Florida, and in Ontario, and overseas, wherever the project requires and the client requires. With that, I'll turn it over to Janet. Thank you so much.
Okay, so we have a few questions in the chat. And again, if you have a question, please just put it in the chat right now and we'll get to as many as we possibly can. Okay, so the first question is from Khalid, and he's asking about a project for Hurricane 5 cat design, and the plot has an old runway. Could you advise if this is the type of foundation that could be used in this project, or what other cost-effective foundation?
Yeah, we'd have to look at what wind speeds are there, but we could design to that. And I have worked on an airport, depending what the runway is made out of, whether we would cross the runway or completely be on a runway, I guess would be the question. But there are solutions for runway. A lot of them are concrete. So we've embedded anchor bolts into concrete for that. Or if the the runway is not suitable, we could look at a ballasted design as well, if it's economical based on the wind speeds that you're speaking of or the hurricane forces.
Thanks, Rob. Okay, our next question is, how do ballasted foundations function on sites in cold regions where the active layer experiences frost heaving, which may cause seasonal movement and settlement of the foundations? Okay, I think I'll turn that over to you, Sam, because you're nodding and smiling.
Yeah, absolutely. We've done, we faced those challenges, but again, due to the, first of all, you do build in such areas, and you expect the settlements. You do build a little bit of a gravel underneath your ballasted tub, and to allow for water and everything, and it helps with the settlement. But due to our product independent table design, then even if there is that settlement, that the tracker can actually, or even the ballast, the fixed tilt can accommodate those settlements within within the allowable tolerance here.
Thanks, Sam. Here's a more technical question. Do the wires run at the back of the purlins, or is there a potential requirement to cab hanger support system to go from rack to DC combiner / box inverter?
Well, that's always comes up. You're right. Probably to gather your strings east to west, you'd use the back channel of the racking, but to go north south, because you can't penetrate the ground, you have to run your cabling above ground. There's room, and we do it a lot of times is we'll put a bracket embedded within the block that you could that you can have a cable management system attached to our ballast block.
Thanks, Rob. The next question comes from Maria. Do your racking systems have adjustable legs that can be adjusted throughout the life of the project as needed?
If we view that, good question. If we view that as a potential problem, we could allow for adjustment. Their concern is if there's more settlement than our racking could accommodate, could we have adjustment points to even out the racking after there was settlement? And yeah, we could incorporate that. That would be just more cost. We wouldn't initially recommend it, but if the site conditions says that's a potential problem, then yeah, we could design that into the system. It's easier for our tracker to have a lot of that adjustments already in there, but for our fixed tilt, we could incorporate some type of hole pattern.
Okay, the next question is asking about the maximum incline these systems work on. And what is the maximum wind rating for these systems? For example, 130 miles per hour winds.
Good question. Depending on the slope and penetration of for the slope on the landfill, say, or the brownfield, we would have, and depending on the direction of the slope, we would have to look at that. The slope isn't as hard for the racking, say if it's going north-south on a fixed tilt, but on an east-west, we typically handle about 15% slope in an east-west direction. North-south, it's more because the racking would be back to back going up a hill. But we could look at those conditions for the ballast block. We level the block on the slope with compacted gravel. So we'd have to look at that as well for the block.
Thanks, Rob. The next question comes from Lydia Brown, and it says, how does ballasted racking costs line up with typical pile-driven systems? So I think she's wondering whether one is more expensive than the other, or do they pretty much line up?
A ballasted system would be more expensive material-wise and labor-wise, but a lot of times the land is less expensive. So that balances out. So the property is less expensive, but yeah, the ballasted systems typically more expensive install cost and material product cost.
Mainly, just to add, Robert, they're mainly depending on the foundation you're comparing with. If you're comparing to a foundation of like 3 feet embedment depth, yes, but if you're civil engineer and geotech engineer, they come and they say, hey, it's a 20 feet embedment depth, then your ballasted design could be very well competitive there. So it highly contingent on the subsoil surface.
Yeah, if you tried using, say, a driven post I-beam C channel on a site where you're going to get a ton of refusals, then you're going to spend that difference in remediation costs. So it's site dependent, but yeah, if there's a lot of obstructions in the ground, there's peace of mind that you're not going to hit any when you're doing a ballasted solution.
Thanks, Rob and Sam. The next one comes from Waco Metals. Where are the screwed-in piles or pile-driven for the foundation preferred over the ballast application? So I think they're asking over the reverse scenario for when you would use ballasted foundation.
I'm not sure I understood the question correctly, but yeah, it mainly starts with, if the first question is, can you penetrate through the ground? If the answer is yes, then obviously driven piles, helicals, micro piles with concrete, whatever the case is, there it's an option, and you can investigate and look through that. And based on the feedback you have from your geotech analysis and from your pull-out testing, then you can make that decision more wisely, and it becomes a more educated decision which one is more feasible. Is it a ballasted, or is it like a penetrated foundation design?
Thanks, Sam. David asks, what is the PSI exerted on the ground for the precast option? Some brownfield sites I've done have been landfills covered with geotextiles.
Yeah, you'd have to look at the requirement. Like the site I'm working on right now is at 10 psi, a maximum 10 psi requirement, and our ballast there's not an issue. We put 1.3 to 1.7 yards of concrete per tub, and we haven't exceeded that psi. Primarily, I think the concern is heavy equipment. Rutting the site is where the major concern is, like cement trucks, telehandlers, things like that. The heavy equipment tends to damage the cap and the vegetation more. So, but we haven't had a site where, we had to change our tub design at least to distribute the weight more. We could do it, but we haven't run into that thus far.
Okay, thanks, Rob. And then Wyatt asks, and this is so far the last question in the chat, when working on a brownfield landfill site, is there concern regarding the bearing capacity of the soil? Are these sites more likely to experience deflection throughout the lifetime of the solar farm?
Yeah, good question. And that's done in the geotech. Your engineers will look at the bearing capacity, and sometimes you might even want to put a block or a couple blocks in the field if you have the time, and actually do a study yourself with the product if there's time. Some projects last a few years, so it's possible, and some of the bigger projects you have that time. But yeah, the geotechnical engineer will look at the bearing capacity of the land and the soil, and will basically set up the parameters for that brownfield or landfill.
Right. And it's also highly dependent on what is buried in the landfill. Are things actually buried in the landfill, or is it like contaminated brownfield? So yeah, all those take consideration to what Rob was saying. Yeah.
All right, that's the last question that we have. So thanks, everyone. Just a reminder, if you want to reach out to Sam or Rob with any sort of questions, please, their information is here on the slide, on this one and on the next one. We will be posting the video of the webinar, and we'll be sharing out to anyone who has registered for the webinar. You can share that with any of your colleagues. If you do want to get a copy of the slides, please let us know and we'll send it to you separately. And thanks very much for your time and have a great rest of your day.
Thank you, everyone. Thanks for joining.
Thanks, everyone. Take care.